Hello everyone, and welcome to another video on Python programming. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered, arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? Lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains three objects 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if two lists contain the exact same elements, if the elements are placed in a different order, the two lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3, the same elements but in different order, I will use the is function to check whether these two lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have two lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list, and I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I want to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider every second element essentially. So what it will do is it will go here, and then it will skip one, and then go here, and then skip one, And that's essentially what we it's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. All right. So let's see what happens when I take every second element. It should give me it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say a minus 1, it's essentially looking at the last element of the list. So it gives me the sixth or the last element, which is the object 6. If I did a minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax: double colon, and we give a minus 1. What this tells the system is I want the list A, but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be two similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this, and I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication, or a replication function, where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's the 3 strings: eggs, apples, and carrots, and I have 5 int objects, 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with say mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first 3 elements. I want to replace mango, I want to replace apple, and carrot. So what I will do is I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with 3 different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my 3 elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, 3 elements with only 1 or 2 elements, that is also possible. So now if I want to replace the first 3 elements, kiwi, orange, and sponge, with just 1 element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, 3 elements have been replaced with 1 wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with 3 different elements, an obvious way would be just consider that element's index and then put whatever objects you want. Say I want to add, instead of wine, I want to add beer, I want to add ball, and say club. Yeah, well, let's see what happens. Now if I say B, check what's inside my, you can see my elements have been added, but they seem to have been added as is, I had entered a list over here, and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace one, if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine, and I had 1, 2, 3, 4, and 5. Now if I do this, B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace. It will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have I've removed wine, and in place of it I've put beer, ball, and club, but these three are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2, and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append 3 different objects. I want to append 5, 6, and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list, and this is not what I wanted. I wanted 5, 6, and 7 to be individually placed, and we do have a way of doing that, and the way to do that is the extend function. That is what I'll show you next. Now if I want to extend, say, the original list by 3 different elements, 8, 9, 10. When I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parentheses, you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, alright, this number, if I want 8 itself removed, what I will do is put the value 8 here and it will remove it from my list. So if I check my list A, as you can see, the value 8 has, it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list, but unlike remove, the pop function actually outputs a value and that value is what we have popped out of the list. So by default it will pop out the rightmost value of a list or rightmost element of a list, and in this case that element is 10, so it should give me 10. But of course if we want to pop out any particular object, in this case we do not give that particular object, we give its index. So now say if I want to remove this list object from my bigger list, as I can see it's in index 0, 1, 2, 3, 4th, it's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in 2 key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2, and 3. And the next very important property that is different or that differentiates tuples from lists is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list, or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to, or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I would be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3 and 4 tuple into t, let's unpack it into another tuple. Let's call this, let's put these elements into this tuple, and I put this into t. Alright, now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in b, it gives me the value 2. If I see what's in 3, it gives me value 3, and d gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into t, and then put that tuple t into this tuple a, b, and c, d. So what has happened essentially is the element a has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto a, 2 has been unpacked onto b, 3 has been unpacked onto c, 4 has been unpacked onto d. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to a, 2 to b, 3 to c, 4 to d. I have matched these two tuples together like this, and this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements on this tuple and the elements on this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright? In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did x, comma y, comma z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in x, it is actually 5. If I see what's the value in y, it is 6. If I see what is the value of x and z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. So yeah, this is it for lists and tuples, and I hope you understood some of the concepts surrounding lists and tuples. And as always, if you enjoyed this video, do drop a like and do subscribe to our channel. It helps us a lot, and I hope to see you in the next video. Thank you for watching.